Hello, this is Bobby at Coppell TV Repair with a video today that we make for a customer of ours and anyone else that may use it later on. It is about how to test power supply board BN44-00618A. You can find the number printed here, BN44. There is no dash, and the full part name there is 00618A. There's a number of boards that are based on the same PCB. There's actually a little table here on this side that lists them all, and usually we have the one that is marked, checked here in a box, but the white label is a better indication for that. And this is not a 100% reliability test for that board. It is 99.9% reliability test for the board. I will get on that after a minute. We test the board without any connection, without any cable connected to it other than the main AC cable. It provides 110. And we'll be looking at that connector at the lower right corner, which is where the main board is connected, and that little table here that gives you the meanings of the two rows of pins on the main connector. As you can see, if you look closely, the very top left pin is marked by STBY, which means standby, and this is the standby power that's provided by this small transformer on the board. This is the very minimal power that is needed for the main board in order to keep the TV awake, and basically provide the very minimal functionality of standing by and waiting for TV to be actually turned on. The rest of the board at that point is not functional. Again, very small power coming from here, going to that standby pin. It's 5 volts, and waiting for something to happen. How does it know something is happening? Well, the very next pin to it is called PS on. That comes from power supply on. The main board sends back a signal to that top right pin when the board needs to wake up, and the TV will start waking up in turn as well. The waking up goes in 2 steps. In the first one, upon power supply activation, the relay will click, the power factor correction circuit will activate, and 400 volts will appear on those capacitors here. I don't explain everything that, what it means, just the steps that will happen. And a number of voltages on the rest of this connector will show up, like the D5.3 volts. That is the same 5.3 from the standby, except this can carry a whole lot more juice. What that means is it can carry the 5 volts even when loaded, and it can give actually exactly how much amps it can give is set by another table. It will be 4 amps, if you can see there at the very last column, where the standby is a mere 0.2 amps. That's really nothing. You can't power well, a USB memory you can, but nothing else. You can't charge with that. While 4 amps is something similar, something more serious, and this is being provided when the power board is activated. But that's not all. Another voltage that will show up is the D15 volts here, which is needed for other, that's 15 volts, which is needed for other boards. So measuring those will tell that the first step is pretty much complete, and the board does have a built-in monitoring protection where if it's told to wake up and those voltages do not appear out and are not proper, meaning too low or too high, the board has built-in watchdogs that will shut it off. So if there's anything wrong, you will hear click followed by another click, or you may not even hear once click at all when you try to turn on the board. One simple word on turning on the board: we'll be doing this manually. We'll not be using external board for the sake of eliminating the odds of that external board being bad, and that's why this board not coming up. Some boards require that anywhere between 2.5 and 5 volts is being sent to them to tell them that something needs to happen. This is the activation, the signaling pin, the top right that says power on. So some boards will require that you send them logical 1, that is between 2.5 and 5 volts most of the time, in order for them to activate. Some boards, however, and those are most Samsung power supply boards, are the other way around. They will have a logical 1 on that pin, the signaling pin, and they will require that the external signaling device, in this case it will be us, normally it is the main board, the external signaling device will be grounding it down, shorting it to the ground, this or this, and best any of the ground pin on the connector itself that says GND, lower to left, for example, but this will do as well. So in order to activate that board in the first step, you need to short that PSON pin before you can measure any voltages. Now, enough theory, let's try for some actual measuring, and please forgive me for putting that red crocodile on the blue, on the ground black probe, but that's how I'm going to do it. I am taking one of the 2 pins. This is my meter, and what we have here is on the first pin. Let me increase the range so that it doesn't waste time searching. On the first pin, which is standby, I have 5.25 volts. That is the standby power. This is what's needed by the main board to just keep on listening for pressing buttons and whatnot in order for the TV to happen. So on the pin next to it, the second pin here, top right, which is labeled PS on, as I said earlier. So on that pin, I have 4.24 volts, and this is the active one that I told you that is supposed to be grounded in order for the board to wake up and provide voltages on the other pins. Now let's try some of the other ones. Let's say D15 volts, which happens to be the second pin from top. We have 0 here, nothing. So what I'm going to do now, one really simple way to activate the board is to just short the top right pin and the one below it, because they are power on and ground respectively, shown here. So you can even do it with a probe like this. I don't know if you can hear that. It comes from the relay. This is the relay on the board, and I don't know if you can hear it, but when I touch those 2, it clicks. Now, because I can't hold and measure, I'm going to be using, you can use a hard drive selector jumper for those, or other things. I'm going to use one cable like this from a contact cable to short those 2 out. Let me see how this will happen best. The best way for it to happen will be to just make separate one cable from the top. So one is connected at the top, the next one right next to it. So I'm just getting a cable that allows me to do 2 plugs on those 2 pins. Again, you can use a jumper, you can use anything. That's just a cable that shorts the top and the bottom pin. And here's what you have now. You still have 5 volts standby here, that's normal, on the very top pin. But on the one below it, it says D15 volts. Now you have, this is the second pin, making sure we don't short it with the third one. Now you have 15 volts, just as it says. And now you will have 400 volts on those capacitors too. Let me see if I really do. I said this is the minus, so let's try it that way. Increasing the range to 600, 396.7, that's good enough. whether it's 396 or 400 doesn't really matter. That's 1% variation. So the board is now activated halfway. What it needs is one more signaling. If you look at that board, the biggest power consumer in any plasma TV is the panel, and it's so big that it deserves its separate activation circuit and separate steps for activating it, which is why on that board there is a selector here which is called VS on, the very bottom right, and that pin needs to be given logical 1, that is between 2.5 and 5 volts, in order for those two transformers to get activated, and they will produce the two high power and high voltage outputs from the power supply board, VA, which can be measured here, and VS, which can be measured up here. Values for them can be found on that table. 2.7 for VS, if I remember well. VA is 55, 63 at 1 amp. VS is, I don't see it printed, I know it's there. 63, from 219 to 14. Minimum maximum in the lower table. Oh, that's for 51 inch and for 64 inch. There are two tables. And the second to last row gives you the voltage that will be outputted. Over 200, and staying stable is pretty much reliable indication of what it should be. So here's how it works. I'm going to get another one of those cables that I'm going to be using for jumping. Hard drive jumper is harder to be used here because there is no 5 volt source nearby. What I'm going to be using for 5 volts will be the D5 volt from the second pin, or possibly even the standby. Let me straighten that up and see how to plug it in without damaging anything. Is there a better way to get 5 volts here? 1, 2, 3. And the third from top looks good. Okay, so what I did was I jumped the last on the right with the 1, 2, third, which is D5.3 volts. And what I suspect I will be having as a result, please pardon the bad video quality, I gotta get a better phone for making videos, is 244 volts stable. VA on this side is stable 55. Working high, let me move that here. And again, VA 55, VS 245. VS can be adjusted from here if necessary. The proper value for 64-inch monitor is between 219 and 214. That's too high. So both of those are a little on the high end, and what we will need to do is adjust them a little bit from here. The best way to do that will be, of course, while we are measuring them, which is kind of hard with one hand, but that is the general idea. So this is 216, let me see, 36. Okay, that looks too high. And I'll take a look at why that is and why it doesn't adjust. I'm not really 100% sure why would that be. I will follow up on that, but The rest of the test does not make it any different. Not even sure that is proper, but that is proper. 220 sounds more like it. 220 volts for a 64-inch rather than 240. So we'll look up why is the the VS a little out of range, and more importantly, why it couldn't be adjusted. But the very presence of it being there is an indication that the board will most likely, even if it's 20 volts above what it should be, it will still come up with an image. And if there is a too bright image, too dark, issues like that, that might be because the voltage is out of range. But other than that, the typical failures on those boards are not related up here. This might be whatever, bad contact, something because of the handling of the board. We'll take care of that when we test it. But when there is a problem, the board will just not stay on and not give you those outputs. So I hope that helps. Pardon the minor technical difficulties.